You're 18 months into a migration and running a slower, more fragile distributed monolith. Breaking up a monolith sounds straightforward on a whiteboard, and then 18 months later, you're running a distributed monolith that's slower, more fragile, and harder to ship than what you started with. If you are facing this problem, you're in the right place. My name is Mukesh Alex Vaidya, and I am an enterprise architect with more than 20 years of experience designing, building, and modernizing enterprise software systems across banking, insurance, fintech, and e-commerce industries. Throughout my career, I've helped organizations solve complex technology challenges involving Java, Spring Boot, microservices, AWS Cloud, APIs, DevOps, and large-scale digital transformation initiatives. What I've learned is that most modernization projects don't fail because of technology. They fail because organizations lack a clear architecture strategy, migration roadmap, and practical execution plan. So today I'm going to tell you the real reasons these migrations fail and what the teams who actually succeed do differently. If we haven't met, I've spent about 20 years as an architect, a lot of that time inside large enterprises, untangling exactly these kinds of systems. Banks, insurers, platforms with millions of lines of Java that have been running since before some of their engineers were in high school. So when I talk about monolith migrations, I'm not talking about a side project. I'm talking about the migrations that have a board-level budget attached and a CTO whose job is on the line. By the end, you'll be able to look at your own migration plan and spot the cracks before they cost you a year. Let's get into it. The number one reason migrations fail is that they should never have started. Somebody, and it's usually not the customer, decided the monolith was legacy. Legacy became a dirty word, and microservices became the cure for a disease nobody actually diagnosed. So I always ask one question first. What business outcome does this migration buy you? Faster releases? Fine. But is the monolith actually what's slowing your releases, or is it your deployment process and your approval chain? Because if it's the process, microservices won't save you. You'll just have the same slow process now spread across 40 repositories. Scaling? Most monoliths scale fine horizontally if the database can keep up. And splitting the app doesn't fix the database. When you can't name the specific business pain in one sentence, the migration has no finish line. And a project with no finish line doesn't fail loudly. It just quietly never ends. And I want to be fair here, because sometimes the answer is yes, you should migrate. If different parts of your system genuinely need to scale independently, if you have teams stepping on each other in the same codebase every single day, if your release cadence is being held hostage by one fragile module, those are real reasons. The point isn't that migration is always wrong. The point is that you have to earn the decision with a concrete problem, not inherit it from a conference talk. The plan looks clean on a slide. We'll build the new microservices platform, migrate everything over, then flip the switch. A nice, tidy big bang. Here's what actually happens. While you're building the shiny new system, the old monolith doesn't freeze. The business keeps shipping features into it. So now you're chasing a moving target. Every feature added to the old system is a feature you have to re-implement in the new one. I've seen teams spend a year building toward a switchover that never comes, because the monolith they were trying to replace grew faster than they could rebuild it. The teams that succeed do the opposite. They use the strangler-fig pattern. You wrap the monolith, route one slice of traffic at a time to a new service, and let the old system slowly shrink while the new one grows. Every step ships to production. Every step delivers value. And if you stop halfway, you still have a working system. That's the test. A good migration can survive being paused. A big bang can't. This is the most expensive failure, because it looks like success. You split the monolith into services. You've got the diagrams. Everyone's proud. But the services all call each other synchronously. They share one database, and you can't deploy any of them independently. Congratulations! You've built a distributed monolith. You took all the downsides of a monolith and added network calls, latency, and partial failure on top. Now a single user request fans out to 12 services. One of them is slow, and the whole thing times out. And good luck debugging it, because the stack trace is spread across 12 log files on 12 machines. The root cause is almost always the same. The boundaries were drawn wrong. People split by technical layer, a service for the controllers, a service for the data access, instead of by business capability. Get your boundaries from the business domain. Where does the data naturally live together? Where do changes happen together? That's your service. If two services always have to change at the same time and deploy at the same time, they were never two services. They're one. Here's the one that quietly sinks the most projects: the data. Splitting the application code is the easy half. Everybody focuses on it because it's the visible half. But underneath, there's usually one giant shared database, and every part of the system reaches into every table. You can't have true independent services if they're all married to the same tables. The moment two services share a table, you can't change that schema without coordinating both of them. And coordination is exactly what you were trying to escape. So the real work is pulling the data apart. And that's hard, because the moment you split the database, you lose the thing your monolith gave you for free: transactions. In the monolith, you could update 3 tables in one atomic commit. Across services, that single commit becomes a distributed coordination problem: sagas, eventual consistency, compensating actions. Suddenly your team has to reason about what happens when step 3 fails after step 2 already succeeded. That's a serious engineering investment, and most plans budget 0 time for it. They scope the code migration and treat the data as a footnote. The data isn't a footnote. The data is the migration. Let me make this concrete. I worked with a team that had pulled out a clean little orders service. Beautiful code. They were thrilled. But the orders table still lived in the shared database, and the billing logic, the reporting jobs, and 3 batch processes all read from it directly. So every time they wanted to change the orders schema, they had to get 4 other teams in a room. They had a microservice in name, and a monolith in every way that actually mattered. It took them longer to untangle that one table than it took to write the entire service. That is the part nobody warns you about. Let's say you do split things up correctly. Now you have to operate 40 services instead of 1, and most teams aren't ready for that on day 1. With a monolith, life is simple. One thing to deploy, one log to read, one process to restart when it misbehaves. The day you go to microservices, you've signed up for distributed tracing, centralized logging, service discovery, health checks, automated deployments, secrets management, a whole operational platform. If you don't build that first, your engineers are flying blind. A request fails and nobody can tell you which of the 40 services caused it. This is why I tell leaders, microservices are mostly an operations and organization decision wearing an architecture costume. If your team can't deploy the monolith confidently on a Friday afternoon today, splitting it into 40 pieces won't fix your discipline. It'll multiply the chaos by 40.
Like, earn the right to distribute. Get your deployment, your monitoring, and your on-call in shape before you add the complexity.
And here's the one almost nobody puts on the slide: the organization. There's an old observation called Conway's law. Your system architecture ends up mirroring your communication structure. If you have one big team with one big approval process, you will build one big, tightly coupled system, no matter how many service boundaries you draw. I've seen teams ship microservices that still required a release committee to sign off on every deployment. So all 12 services ship together on the same date every 2 weeks. That's not microservices. That's a monolith with extra steps and a worse latency profile. If you want independent services, you need independent teams. Teams that own a service end-to-end and can ship it without asking permission. Change the org chart or don't bother changing the architecture. So, most Java monolith migrations don't fail because of Java, and they don't fail because of Kubernetes or whatever framework is trending this quarter. They fail because of unclear goals, wrong boundaries, ignored data, missing operational maturity, and an organization that never changed. Get those right, and the technology mostly takes care of itself. If you've got a migration on the table, and you're not sure whether it's the right call, that's genuinely my favorite kind of problem to think through. And I share how I work through these in pretty much every video on this channel. So if this was useful, subscribe and stick around, because the next one is on a question I get constantly. ECS versus EKS. Which one should you actually choose? I'll see you in that one.